Hello and welcome to The Explainer. Today, we're tackling a really big question in AI. What if making our models smarter isn't just about making them bigger? What if it's about making them, well, smarter and how they think?
For years, the thinking in AI has been pretty simple. Scale is everything. Just build bigger models, throw more data at them, use more computing power, and boom, they get smarter. But what if that's not the whole picture?
Because it turns out, when you get to the really complex problems, like advanced math, that whole brute force approach just stops working. We're hitting a wall where just adding more power isn't giving us those big breakthroughs anymore.
And this isn't just a feeling. Researchers actually have a name for it, the AI reasoning wall. They're seeing that for some of these tough problems, we've basically hit a performance plateau. They can run thousands and thousands of extra training sessions, and the models just don't get much better.
And you can see it right here. At the beginning, sure, more training gives you a nice performance bump. But look what happens over time. The more you train, the smaller those gains get, until they're almost nothing. We're burning an incredible amount of energy for these tiny improvements. It's the classic definition of diminishing returns.
Okay, so what's really going on here? If just throwing more power at it isn't the answer, what are we missing? Well, it seems the problem isn't about how long the AI trains, but how it trains.
Think about it this way. The current method is basically a brute force attack. It's like trying to solve a puzzle by trying the exact same strategy over and over and over again, just hoping to do it a little faster each time. The new idea is, what if we could teach the AI to think more strategically from the very beginning? And this gets right to the core of the problem, which is something called sparse exploration. Imagine you're trying to solve a super complex maze. The way current AI models work, it's like they only ever check one or two paths. They might run down those same paths again and again, getting faster each time, but they completely ignore all the other possible routes, including, the one that actually leads to the exit.
So, if brute force and just exploring a couple of paths is the problem, what's the solution? Well, this is where a much smarter strategy comes into play, one that's all about teaching the AI how to be a better, more thorough explorer.
And this is where a new framework called DeepSearch enters the picture. What's so clever about it is that it builds a structured search process directly into the AI's training loop. It's not just about getting the right answer. It's about teaching the model how to think and explore possibilities much more effectively, right from the get-go.
This really is a fundamental shift in philosophy. We're moving away from just scaling training depth, which, let's be honest, just means doing the same thing for longer, and we're moving towards scaling training breadth. The whole goal is to train the AI to explore a much wider range of different reasoning paths.
Okay, so how does DeepSearch actually pull this off? How does it encourage this wider exploration? It's not just one little trick. It's actually a pretty cool combination of three key innovations, all working together.
First, it uses something called a global search to kind of get a bird's-eye view of the entire problem. This helps it find the most promising paths to even start exploring. Then, and this is my favorite part, it uses guided learning. It actually forces the model to learn from its biggest mistakes, especially when it was super confident but totally wrong. It's like learning from your overconfidence. And finally, solution caching just makes the whole thing way more efficient. It remembers the answers to problems it's already solved, so it doesn't waste time redoing the same work.
All right, so the theory sounds great, but does this smarter approach actually work in practice? Well, the results aren't just a little bit better, they're pretty staggering. This is where we see it all come together. Better, faster, and, believe it or not, cheaper.
Check this out. On a set of really tough math reasoning benchmarks, DeepSearch hit an accuracy of nearly 63%. That set a brand new state-of-the-art record for models of its size. It's definitive proof that this smarter way of training delivers way better performance. But here's the real kicker. It got that record-breaking performance while using 5.7 times less computing power than the old brute force method. So it's not just smarter, it's insanely more efficient. Let's just put these numbers side by side so you can really see the difference. The old way, extended training, took over 1,800 GPU hours just to get to a 62% score. DeepSearch not only beat that score, but it did it using only 330 GPU hours. That's a better result using just a tiny fraction of the resources. It's incredible.
So, what does all of this mean for the future of AI? This isn't just about one cool algorithm. This could really signal a whole new direction for how we build and train these models.
You know, the researchers behind DeepSearch really said it best themselves. They conclude that this points to a future of scaling reasoning capabilities through systematic search rather than prolonged computation. In plain English, the future isn't just about more horsepower, it's about having a smarter engine.
And that really leaves us with a final, and I think very important question. For so long we've been in this arms race to just build bigger and bigger machines. But maybe, just maybe, the next great leap forward in AI won't come from a bigger computer, but from a better idea.